Alrighty, welcome everyone. So today we're going to be having a look at reducing balance loans. Now these are really to do with how do you actually pay back loans, right? You have two options. I borrow $1,000 from the bank. Well, either in 6 months I say, hi bank, here's the $1,000 plus the interest that it's accrued over that time. So, now it might be $1,200. So I borrowed $1,000 and 6 months later I paid back $1,200. But that's not the more common type. The more common type is the type of loan in which you take out $1,000 and every month you're going to pay back a certain amount to the bank until you don't owe them anymore. That's going to be the goal of today. So you're able to model things that look like that. Now it shouldn't look too unfamiliar, this formula here. AN plus 1 equals RAN. That's how we model compound interest. The only difference is now we have this little minus R thing. And R is just the repayments. How much do you repay each month, or each week, or each quarter? Okay? So, let's just imagine for a second that at the very beginning I take out a loan, and that loan is $6,000. Alright? Now each month it's going to gain a bit of interest, but I'm going to pay a little bit back. The interest it's going to get, I'm actually going to convert it to a monthly interest just for the minute to make it nice and easy. So I'll say that each month it grows by 2% monthly. And each month my repayments are going to be, say, $400. $400 might not be enough. We might say each month I pay back $500 of my loan to try to pay it off. Righty, so we've got these little pieces to play with. I still need to work out my R, my lowercase r. Well, that's just going to be 1 plus 0.02, 1.02%, oh, not percent, as just a number. So my formula now looks like this. AN plus 1 equals how do we read it? The next term is equal to 1.02 times the previous term, subtract $500. And our goal is for this to actually get to 0 eventually. So let's see how it goes. Starting with, we won't see how it goes just yet. I want to see if you can have a go at this as well. So let's imagine we have A0 equal to, well, we'll keep it the same, $6,000. I is equal to 3% per quarter. R is equal to $800. Could you write me a recurrence relation that will relate each value of the account over several different quarters? Alright, so this is a quarter question, which means that everything is going to be just thought in quarters. So $6,000 in a quarter, it's going to be 3% bigger, but I'm going to take $800 away. First thing I need to work out, like always, is my R, which is always just 1 plus I. And since everything's already in quarters, I don't need to do any conversions. So AN plus 1 is equal to 1.03 AN minus $800. Because how do I read it? The next value is going to be the previous value times 1.03 minus 800. So now I've just got to do two things. Well, let's actually see how my one plays with. Now, let's just start off. So A0 is 6,000. So I'm starting with 6,000. Let's work out what A1 is going to be. Well, A1 is going to be 1.02 times 6,000 minus 500. So let's work that out. Alrighty, so 1.02 times 6,000 minus 500 gives me 5,620. Okay? So that's the next value of my account. Let's work out the value after that. A2. Well, 1.02 times the previous amount minus 500. Alrighty, so now we're down to $5,232.40. So you can see that month by month, my loan is going down, and that is a good thing. Each month, the value of the A should get down because it is a loan, and loans should get paid back, and in that way, eventually paid off. And so looking at this, maybe in a little bit more than a year or so, I'd be able to pay off this loan if every month I keep paying $500. And if I were to change that repayment amount, it would change the amount of time it would take to pay off the bill. I'm not going to go any further with that, but reminding that your A0 is, I think it was 6,000 as well, wasn't it? So your A0 is 6,000. Can you just have a play and check that you can generate A1 and A2 of your account using your recurrence relation? So pause the video, try to work those out. Alrighty, so let's have a go, see how it goes. So for A1 is going to be 1.03 times 6,000 minus 800. So at the end of one quarter, because yours is talking in quarters, it's going to be 1.03 times 6,000 minus 800. So $5,380. And you'll see that yours will shrink a lot faster than mine because your payments are greater. So your A2 should be even smaller then. Oh, made a mistake. See the 6,000 here? Shouldn't be there. Because it's not of the starting, it's of the previous term. $4,741.40. So, after 2 quarters, or half a year, you'd be left with $4,700 to pay off still. So this is a basic introduction into our loans. Now before we move on, I just want to quickly remind ourselves how to just deal with slightly more complicated situations. So let's say Martin takes out a $5,000 loan. And the interest he's getting on that, which is not a good thing, right, is going to be 16% per annum, compounded, and we will say quarterly. Alrighty. Now the repayments he's going to be making is going to be of, we'll say $800 per quarter. Find a recurrence relation for this situation. First thing, got to find my R. Problem is, it's compounding quarterly, but this is per annum, meaning it's a yearly rate. So that's the first thing I'm going to need to deal with. So I is equal to 16% per annum, but I want it as a quarterly rate. Divide by 4 to make it quarterly, so that's 4% per quarter. Now I can find R. 1 plus 0.04, 1.04, that's my R value, little r, and now I'm going to use the formula. AN plus 1 equals RAN, take capital R, and my repayments were 800. Alrighty, so your question is going to look like this, $5,000, and we'll say 12% per annum, compounded monthly, with monthly repayments of $250 per month. Alrighty, so pause the video, see if you can figure out what the recurrence relation for that one would be. Alrighty, so let's actually have a go through and do it. So, first of all, we've got to do that I playing around with business, so 12% per annum, but we want it as a monthly. Got to divide it by 12, so it's 1% per month, and that means R is going to be 1 plus 0.01, or 1.01. And our formula will end up looking like this. Alright, so it's really important that everything's in the same rate. Everything's got to be quarterly or per quarter for it to work. If you've got anything that's annual or anything else, it's going to mess up with your thing. So before we finish up, my question is going to be this. Using your equation, how much will the value of the loan be in, we'll say, 3 months? So how much will it be valued in 3 months? Remembering both of us are starting off with $5,000 loans. So for both of us, A0 equals 5,000. So what is the value after 3 months? Well, I'm going to show you for mine first. So how am I going to figure out the value in 3 quarters? Because mine's in quarters. Well, after 1 quarter, it's going to be 1.04 times 5,000 minus 800. Let's work it out. 1.04 times 5,000 minus 800. So 4,400. After 2 months, it's going to be the same. 1.04 This is a really useful time to making sure that you know how to use the arrow keys to edit. Saves so much time. And after 3 quarters, $3,127.04. So after 3 quarters, that's how much my loan is going to be. So hopefully you can have a go at yours and see if you can see how much yours is going to be worth in for 3 months. Alrighty, well, let's have a look. A1 is equal to 1.01 times 5,000 minus 250. So after one month, we're left with 4,800. Now this is a really good sign that it's going down, because sometimes your A2 should have gotten 4,598, and your A3 you should have got 4,393 and 98 cents. So that is a quick introduction into modeling reducing balance loans with recurrence relations. Hope you've understood everything. Got any questions? Make sure you let me know. Alrighty, see you next time. Bye-bye.